Hey everyone, this is Mukesh from codewithmukesh.com, and in this video, we'll be learning about AWS Lambda in .NET and various other related topics. We'll discuss about the use case of AWS Lambda, installing the required extensions and templates, how easy it is to create AWS Lambda C# projects, getting them deployed to AWS as well as debugging them locally. This should be more than enough to get you started with some serverless concepts. And apart from this, we'll also look into another service of AWS, which is AWS Cloudwatch for logging purposes. This video is sponsored by AWS and is part of my ongoing .NET on AWS series, for which I have already posted a couple of videos and articles both on my YouTube channel and my blog. I will leave the required links in the description box in case you want to follow along. Let's get started. What are serverless applications? You might have noticed an ongoing trend where organizations are moving existing pieces of their systems into serverless architectures. So this is a common use case in systems with multiple microservices. Now, serverless doesn't actually mean that there are no servers involved, but the responsibility of managing these servers are taken up by the cloud providers, not you or your team. In our case, AWS will be the cloud provider that will handle this for us. This means that we have to focus only on writing the code. You no longer have to worry about infrastructure, scaling servers, provisioning, or configuring them. This solution follows a pay-as-you-go model, meaning that you will be charged only for the time your code actually gets executed on the cloud infrastructure, or in other words, whenever you consume the compute powers of the cloud provider. Now, this is in total contrast with the earlier cloud approaches where you would provision a Linux or Windows server that will keep an instance of your application running, maybe on some Docker container. So in those cases, you'll be charged for the entire duration your Linux or Windows server are up and running, and you'll also be completely responsible for managing them, patching in new updates, and basically everything. But in case of serverless, AWS will tell you, okay, give me a code, I will host it for you, I will take care of infrastructure provisioning, updates, and all those heavy lifting, just pay me for the time your code runs on my servers. So that's pretty convenient, right? This is applicable not only for running your application instances, but also for other infrastructure concerns like database, messaging, hosting, and so much more. So this is probably the biggest selling point of serverless concept, but there are also few catches to it. We will discuss about this in the later section of the video. Now, AWS provides a bunch of services like AWS Lambda, Amazon API Gateway, DynamoDB, Athena, and so much more that will help you in building serverless applications. For this tutorial, we'll start with AWS Lambda, which is the building block of any AWS related serverless application. In the upcoming videos, we'll explore other serverless services provided by AWS. So, to get notified whenever I post a new video, make sure that you are subscribed to my channel and also hit on that bell icon. The major benefits of serverless applications are that they are readily available. You do not have to architect for these capabilities as they are already available by default. And these services can be configured to autoscale whenever it's needed. The operational cost is almost close to zero. And also, the biggest selling point, the pay-as-you-go model. AWS Lambda is a serverless compute service, which is the basic building block of an AWS serverless application stack. It allows you to execute code without provisioning any servers. So all you need to do is to write code in one of the languages supported by AWS. In our case, it's C# and the currently supported runtime is .NET 6. So AWS has this policy to support up to the latest LTS version of the programming language. Probably by the end of this year, we'll be seeing the .NET 8 support as well. So the idea is that you write your code into an AWS Lambda project in your preferred programming language, which in our case is C#. So these are also called as Lambda functions, which will be deployed to AWS. After hosting the function onto AWS infrastructure, you will be able to invoke these Lambdas in a couple of different ways using API gateways, function URL, triggers, or other AWS services. So once it is invoked, the function will be executed on a highly available compute infrastructure with the request that you have passed, and it will give back the required response. It also scales automatically as required. Lambda functions can also be leveraged to integrate numerous other AWS services, which is yet another added advantage. Note that you will be paying only for the compute time that you have consumed. Now coming to the pricing of AWS Lambda, the free trial account of AWS is pretty generous and offers up to 1 million free requests per month and up to 3 million seconds of compute duration. Note that this is always free every month. In most of the cases, this is more than what you will ever need. In case you exhaust these limits, you'll be charged like $0.2 for every additional million requests. This is a very affordable option if you're looking to host your services to the cloud in a serverless approach. AWS Lambda is best suited for shorter, event-driven workloads since Lambda functions can run up to 15 minutes per invocation. It's kind of ideal for file processing, stream processing, and backends for small-scale or mobile applications. The noticeable features of Lambda are that you can configure environment variables, set a dedicated HTTPS endpoint to invoke a Lambda, configure the memory and CPU size of each Lambda, and so on. Before proceeding, ensure that you have Visual Studio installed, the latest .NET 6 SDK installed on your machine. You should also have a free tier account of AWS and make sure that your system is configured to access the AWS resources. So I generally use the AWS CLI profiles to configure the AWS credentials in my system. This way, I'll be able to access the AWS resources from my system. If you need to do the same, refer to this video where I talk about various ways of credential generation and management. I have linked this video in the description as well. First, let's install AWS Toolkit for Visual Studio. This is an extension that makes it easier to develop, debug, and deploy .NET applications. It will also help you to get started faster and be more productive while building AWS applications. It basically makes the AWS services available directly from Visual Studio rather than you having to go to AWS Management Console every time. Open up Visual Studio. I'm currently using Visual Studio 2022 Community Edition on Windows 11, but I think this extension is available on other popular IDEs as well. So here, click on Extensions, Manage Extensions, and here type in AWS. You'll have to install this AWS Toolkit for Visual Studio 2022. I have already installed this. Once installed, you'll be able to monitor your AWS services, deploy functions and serverless applications, and manage other supported AWS resources. For example, the AWS Explorer gives you a sneak peek of all AWS services like DynamoDB, EC2, RDS, S3, SNS, SQS, and so on. To enable this tab, you can click on View and AWS Explorer. For instance, you'll be able to directly upload files to your S3 bucket using this extension. Apart from this, you will also get a bunch of pre-installed project templates for Lambda and Serverless. If you click on File, New, Project, you'll be able to see the new templates installed, for example, AWS Lambda Project. There are two ways to install the required AWS Lambda templates. One is via this extension, and the other way is using certain terminal commands. You can simply open up a terminal and run .NET new install Amazon Lambda templates, and this should also install the latest templates for you. I'll just switch back to Visual Studio and create a new Lambda project on C#. So File, New Project, AWS Lambda Project. Click on Next. I'll name it First Lambda and the solution as Lambda Demo. Next, we'll have to choose a blueprint for our Lambda project. Blueprints basically contain boilerplate code to get you started easily. So there are several blueprints to write Lambda that integrate with DynamoDB, SNS, SQS, S3, and so on. But for now, since we are just getting started, we'll select the empty function blueprint and create a new project. Alternatively, you can also use CLI commands to create a new Lambda project. Simply open up the terminal again and type in .NET new Lambda empty function. So this will create a new Lambda with the name as test Lambda. Now that we are clear about the ways to create a new Lambda project, let's explore its project structure. As you see, the major components for this project is the configuration file and the actual function. Let's first go through the configuration file, that is AWS Lambda tools default.json. Firstly, the profile. Make sure that it is same as the active CLI profile configured on your machine. For me, it is named as default. Then the region. It denotes the AWS region to which the Lambda will be deployed to. Next is the architecture and the runtime, which is .NET 6. And finally, we have the configuration for memory size and timeout. For now, we'll keep the default values. So the last property of this JSON is the function handler, which actually points to the code to be invoked. So this is the project name, followed by the class name, and then followed by the function name. So in our case, the project name is first Lambda, the class name is function, and the name of the function is function handler. Let's see it. So we go into the first Lambda project, the function class, and here you see the function handler that is mentioned in the JSON. As for the default code in this function, it just takes a string and returns it in uppercase. So without making any changes, let's see how to debug the existing function locally in our machine using Visual Studio 2022. You might think that it would be tricky to debug the Lambda code on your local as it is supposed to run on the AWS infrastructure. For this, we have the Lambda mock tool that can help you debug your Lambda code in local easily. You'll have to install the AWS mock Lambda test tool first. You can refer to this GitHub page, which I'll be attaching on my blog post or this video description. You will just have to install this tool using these following commands. When we created this Lambda project, a launch profile is also created to run our Lambda mock tool. So if you go to Properties, Launch Settings.json, you will see all the configuration related to this profile. To start debugging, simply click on the mock Lambda test tool that you see here on Visual Studio. This will open up the tool on port 5050, which is again configurable from the launch settings.json. The important fields to note here is the configuration file, the function name, the credentials profile, and the AWS region. For our local testing, I'm writing my name in double quotes and hitting on execute function. And you can see the response from the Lambda. As I mentioned earlier, the sample code is capable of converting the smaller case into uppercase. So the tool actually invokes the function code and executes our request. This way, the tooling support is also pretty cool for .NET development. Next, we'll try to deploy this function onto AWS. But before that, let's log into AWS Management Console. From the console, search for Lambda and open it up. So this is the dashboard. As you can see, there are no functions currently uploaded. Under functions, you'll be able to see the list of Lambda functions that are available. For now, there are none. Let's get our first Lambda deployed. So there are a couple of ways to deploy our Lambda code. We'll first see how it can be done using Visual Studio. Let's switch back to Visual Studio, right click on the Lambda project and click on Publish to AWS Lambda. Here, you'll have to select the correct AWS credentials profile, the region, and set the Lambda runtime as .NET 6. I'll name this function as first Lambda as well as the description. Click on Next. In the next screen, select the role. Here, make sure to choose the AWS Lambda Basic Execution role. So every resource deployed to AWS needs roles or a set of permissions. So this selected basic role gives permission to write logs to Cloudwatch, about which we'll discuss later in the video. You can also change the memory and the timeout if you like. Once that is done, hit on Upload. So Visual Studio will start building your project and creating the required resources on AWS. It would probably take around 10 to 20 seconds to completely upload your function to AWS Lambda. Make sure that you have both of these checkboxes selected. This would help in testing the uploaded function straight from Visual Studio. So what happened in the background is that Visual Studio builds the project, publishes the artifacts with release configuration, zips up these files, and uploads a zip file to AWS Lambda with a given configuration. So once the Lambda is deployed, you will be able to see this particular screen to test your Lambda. Here also, give a sample text and hit on Invoke. This time, you're technically invoking the function code that you have uploaded onto AWS and not local. As you see, here is the expected response. Now switch back to the AWS Management Console and refresh the Lambdas. You'll be able to see your first Lambda deployed here. Open it up. So here, under the Code tab, you'll find some important details about the Lambda function, including the packet size, the last modified date, the runtime, and so much more. Switch to the Test tab and under Event.json, enter in a string and click on Next. So I'll do the same thing. I'll just remove this and type in my name and click on Test. So as you see, the request has succeeded and here is the response. And here is the expected response. Now in the Monitor tab, you'll be able to see various stats and logs of the Lambda, like how many times it was invoked, the error rate, and so much more. And finally, in the Configuration tab, under General Configuration, you will be able to modify the memory and storage of the Lambda, including the timeout. As mentioned earlier, you'll also be able to define environment variables here. So just hit on environment variables, edit this one, click on add environment variable, and here you can add the key value pair and click on save. Now, just for demonstration purpose, let's do some minor tweaks to this Lambda function code and republish it to AWS. But this time, we'll be publishing the function from the command line and not from Visual Studio. So I have written a dummy code. Let me just replace it here. Yeah. So here is a dummy code that I added. This time, the request body will be a class named createProductRequest, where we'll be having the name and the description. So this will be saved to an imaginary database and returns a new class along with the product ID. So that's the small change we'll make to our Lambda function. Let's now understand how to publish this function to AWS Lambda using the CLI. So we'll have to first install the AWS Lambda tools on your machine. So for that, you'll have to run this following command on your terminal, that is .NET tool install in a global way amazon.lambda tools. So I'm getting this error since I've already installed this tool on my machine. Note that I'm running this terminal at the root of my Lambda project. Now, to deploy the updated Lambda code, you'll just have to type in .NET Lambda and deploy function. So this is probably take around like 2 to 3 seconds and push out code into the AWS Lambda. It also depends on how large your source code is. So as you can see, the Lambda is successfully pushed. And if you switch back to AWS Management Console, you'll be able to see that the first Lambda function has been modified recently, like 38 seconds ago. This means that we have successfully published the modified code to AWS Lambda via CLI. That's quite easy, right? I wanted to show you one more way to invoke your AWS Lambda using function URLs. So AWS Lambda has this feature where you can create a HTTPS URL using which you can invoke the Lambda. So simply open up our first Lambda, go into configurations and select function URL. So here I'll just click on create function URL, and since this is a demonstration, I'm not going to attach any authentication to this, so I'll just select none and click on save. So this will give me back a function URL. I'll just copy it and go back to Postman with it. So simply open up Postman, paste in the AWS function URL that you got, and I'll just configure the body. So I'll just select it as raw, JSON, and I'll give the required body that it needs. That will be name, and a description if you remember the request body. Once that is done, let me hit that send button. As you can see, it returns a product ID. So if you remember the code from earlier, we have specifically returned a product ID which is a GUID. This is back from the AWS Lambda. Another important aspect of AWS Lambda is the logging mechanism. So AWS services in general have a dedicated logging system known as AWS Cloudwatch. So I'll just search for Cloudwatch here and open it up. So here you can click on the log groups. So each of your AWS service logs would show up here. As you can see, this is the only log group that I have, and it is from our first Lambda. So I'll just open it. So here are the log groups that are available under this particular log stream, that is AWS Lambda, first Lambda. So I'll just search on the log groups. And here are some default logs from the Lambda. Additionally, you can use your own logging implementations like Serilog in the code to write to AWS Cloudwatch. Now let's understand when to use Lambda and when not to. So AWS Lambda is often a better choice compared to spinning up an whole Linux or Windows server instance, which is always running. So as mentioned earlier, AWS Lambda doesn't need you to manage any servers and runs only when required. It is best for running functions that doesn't have an execution time of more than 10 to 15 minutes. So basically, almost all the use cases can be handled with AWS Lambda. Note that scaling is also automated here. The free tier account of AWS allows you to use up to 1 million AWS Lambda requests, which is more than enough unless your app's traffic blows up. A few examples of real-life use case of AWS Lambda is to build a function that can convert or optimize images as soon as they are uploaded in AWS S3. So S3 can trigger AWS Lambda function since it's event-driven. Running cron jobs is also another good use case of AWS Lambda. So each of these Lambda functions can only run up to 15 minutes as I mentioned earlier. Thus, executing long-running functions that are greater than 15 minutes of compute time with millions of records might not be a good use case for using AWS Lambda. Significant waiting time per function may also increase your monthly bills. So keep it simple and neat with AWS Lambda functions. Also keep in mind that there are cold start issues associated with AWS Lambda, meaning that if the function is not invoked for a couple of minutes, the Lambda would go cold, and when the next invocation comes in, it will take the Lambda a couple of extra seconds to boot up the function and environment. That's all for this video. In the next video, we'll learn about Amazon API Gateway in AWS, where we'll build and expose API endpoints that can send in requests to these Lambda functions. So imagine a CRUD functionality where we will have the standard read-write operations. In that case, there will be separate Lambda functions for each of the CRUD operations like create, read, update, and delete. So all these Lambda functions will be tied up together with the help of API Gateway. So that's a very standard example of a serverless application on AWS. You can find the source code of this demonstration in this particular repository, the link to which you can find in the description. The source code of all the upcoming tutorials on my .NET on AWS series playlist will be available in this repository. Apart from this, to read the text version of this video, you can refer to this blog post. I hope you have enjoyed this video. Do not forget to like this video and subscribe to my channel for the upcoming videos. Thanks, and I'll see you again in the next video.